welcome to another video. Hope you're ready to flex those brain muscles because today we're going to talk about radical expressions and how to simplify them. So we moved away a little bit from rational expressions. Those are things that can be expressed as a fraction. And now we're on radical expressions, which are things that are under a root, like this, square root of 12. This is a radical expression. So we're going to use this basic property of roots, right? The fact that we can split these up. And this is the idea that we use to simplify all these radical expressions. And what we're going to do is we're going to take this 12, we're going to take whatever's under the root, and we're going to basically split it up into a product of smaller numbers. So a bunch of smaller numbers being multiplied together. And what we're trying to do is have some of these smaller numbers be square roots that we know, right? Something like 4, 16, 25, 64, something like that, where we have a square root where we know, where we can pull that out, right? And then we're just left with a smaller number under the radical. That's basically the idea. So let's go ahead and do that with this. What two things can we multiply together to get 12, where one of them is something that's the square root we know, and that's just 4 and 3, right? 4 times 3 is 12, and we know that the square root of 4 is 2, right? So we can rewrite this as square root of 4 times 3, and a lot of people just go from this step to 2 square root of 3, but really there's an intermediate step that we kind of skip, and I'll just show it on this problem and then I'll skip it from here on out. But really what you're doing is this square root of 4 times square root of 3, which is 2 times square root of 3. And that's what this is, 2 times square root of 3. This 2 is being multiplied. You just don't see the multiplication symbol because it's implied. It's like if you have 2x, that's 2 times x. And it's the same idea here. So this is what's happening here. You're splitting up these numbers under the radical, and then you're simplifying this to be 2. And square root of 3 you don't know. So, but this is a little simpler than root 12, and you can use this to combine these guys, and you can use them to add and subtract and that sort of thing. So let's do this example. What can we split 50 up into? Let's see, 25 times 2. What if we have 25 and 2? 25 times 2. And that gives us square root of 25 times 2, which equals what? 5 root 2, right? I brought the 25 out, and square root of 25 is 5, so basically the 5 comes out, right? So let's do a few more examples to get some practice. All right, so for this example, we'll do a slightly different way, because maybe you're thinking, okay, this is a lot of pressure. I got to come up with these numbers that are factors of these bigger numbers that happen to be perfect squares, right? What if I can't think of the number? How am I supposed to? And I get it, the numbers get bigger and it's harder to do. So this is another method, and this is actually how I was originally taught to do these. So we'll go ahead and do it. Basically what we're gonna do to this 128 is we're gonna do what's called a prime factorization. So we factor this into the product of a bunch of prime numbers, right? So 2, 3, 5, those kind of things. So we basically break this down as much as we can. So the first step, you just pick any two numbers that multiply together to be 128. I'm gonna pick 32 and 4. And then you just keep breaking things down into prime numbers. This is 2 and 2. This is, let's see, what can I give? 8 and 4. The 4 gives me 2 and 2. And again, you could have done this several different ways. This 8 gives me 4 and 2. And this 4 gives me 2 and 2. All right, so let's see what I have here. 2 times 2 times 2 times 2 times 2 times 2. I have a bunch of 2's, right? 1, 2, 3, 4, 5, 6, 7 2's. So we're basically taking out pairs of 2, right? Because if I have 2 times 2 under a square root, that's 4. And I could take that out as a 2. So each pair of 2's that we can get, we can pull out as a 2, if that makes sense. So I have 3 pairs of 2's. So what's going to come out is 2 times 2 times 2. And what's left in the root is just that 1 2 that's remaining, since I had 7 2's total. So the square root of 2 is remaining. So this simplifies to 8 root 2, right? So just in case you didn't look at this and see that this is 64 times 2, and you could break down 64 to be 8, right? Which will give you the same answer. If you're ever in doubt or confused or you're stuck a little bit, you can always do a prime factorization. And basically you're taking out pairs of numbers, and whatever that number is what's going to end up being outside of the root, right? Since I have 2 2's, I could take it out and it becomes just a 2. So this is a slightly different way to do it. So depending on the problem, kind of depends on which method I use. If it's something where I can clearly identify what I'm going to separate and what's going to be the thing that I'm going to bring out, right? The thing that I know the square root of, then I just go ahead and do that. But if it's something like, 28, for example, I can't think off the top of my head of two things. I mean, maybe I'd think of 4. Maybe 4 times 7, that should give me what I want. But just in case you can't, you could break it up into 2 times 14, and then break up the 14 into 2 times 7, and you can circle the pair of 2's, right? 2 times 14, and 14 is 2 times 7. You have a pair of 2's here, so the 2 is what comes outside of the root, and the 7 is what stays inside, right? So what about this 48? Let's see, I could definitely take a 4, that'd be 4 times 12, but then the 12 I could break down again, right? So let's see, what am I really looking at here? 4 times 12, so let's see. 4 times 12, and the 12 is what? 4 times 3. Square root of 4 is 2, right? That breaks down into 2 and 2. Square root of 4 is 2, that breaks down into 2 and 2. So I'm taking out the square root of 4, and another square root of 4 is coming out. So what's actually coming out is 4 total. It's going to be 2 times 2, which is 4. And what's left in the root is that 3 is left under the root. I could have broke this down. I just ran out of room. I would have wrote this as 2 times 2, circled the pair of 2's, same here. I just kind of ran out of room there. But as you get practice, you can skip some steps. You'll get a lot better at this, and you'll just be doing it like that. Okay, square root of 125. So the thing that jumps out to me is 25. I know that's a perfect square. So I think this can actually be rewritten as 25 times 5. And 5 is prime, so that's as far as this can go. So this is actually just 5 root 5, right? What about this 150? Let's see. 15 and 10. Let's see, 25. We know 25 is a perfect square. So 25, what can I multiply 25 by? 6. By 6, and that gives me 5 root 6, and 6 cannot be broken down more. I can break that down into 3 times 2, but neither of those are known square root or perfect square values, right? So this is actually the final answer, as simple as that gets. So we've seen 2 very similar but slightly different ways of doing this. Pick whichever way works best for you. I kind of switch back and forth sometimes. Once you get an understanding for how this works, you can just kind of do it however you want to do it. But get some more practice, do some practice problems, and leave questions below. Hit the like button, hit subscribe if you enjoyed, and keep making those brain gains. I'll see you in the next video.